So this problem, the statement is A can complete a job in 4 hours. B B and C working together can complete the same job in 3 hours. So I put B plus C. A and C working together can complete the job in 2 hours. So I put A plus C. So the problem is to find in how many hours B can do the job working alone. So first let me find what is the LCM of these three numbers 4, 3 and 2. The LCM of the numbers 4, 3 and 2 is 12. So put the number 12 here. So this 12 is the LCM of 4, 3 and 2, and this is nothing but the total units of work to be done. Now I divide 12 by 4, I get the number 3. So put the number 3 here near this line. 12 by 3 is 4. I put the number 4 near this line. And 12 by 2 is 6. I put the number 6 here near this line. So we have the following interpretations. A's 1 hour work is 3 units. B plus C's 1 hour work is 4 units. And A plus C's 1 hour work is 6 units. And the total units of work is 12 units. Now, what is required in the problem? You have to find in how many hours B can do the job working alone. So for that, I have to find what is a B's 1 day's work. I have these three interpretations with me, and I'm required to find what is B's 1 day's work so that I can find the solution to this problem. So for that, first I'm going to use these two interpretations. That is A's 1 hour work is 3 units and B plus C's 1 hour work is 4 units. So from this two interpretations, I can write A plus B plus C's 1 hour work is nothing but A's 1 hour work plus B plus C's 1 hour work. So that is nothing but 7 units. Right? So A's 1 hour work is 3 units and B plus C's 1 hour work is 4 units. So A plus B plus C's 1 hour work is 7 units. That means if A, B and C works together for 1 hour, they can complete 7 units of the work. Now I'm going to combine these two interpretations. That is A plus C's 1 hour work is 6 units and A plus B plus C's 1 hour work is 7 units. I'm going to use these two interpretations. So therefore, what is B's 1 hour work? So B's 1 hour work is nothing but A plus B plus C's 1 hour work minus A plus C's 1 hour work. It is just like writing B as A plus B plus C minus of A plus C. So that is nothing but a 7 minus 6. So that is equal to 1 unit. So now I'm having B's 1 hour work is 1 unit. So now using these two data, that is the total units of work is 12 units and B's 1 hour work is 1 unit. So from this two I can find what is the time required by B alone to complete the job. So how to find that? So Therefore, the number of days, the number of hours required by B alone to complete the job is the total number of units is 12, and B's 1 hour work is 1 unit, so 12 by 1, so that is equal to 12 hours. So if B alone works, then he needs 12 hours to complete the job. Look at this problem. A and B working together can complete the job in 12 days. So I put A plus B as 12. B and C working together can complete the same job in 15 days. So I put B plus C as 15. A and C working together can complete the job in 20 days. So I put A plus C as 20. Now we find what is the LCM of 12, 15 and 20. The LCM of these three numbers is 60. So 60 is the total units of work to be done. Now we divide 60 by 12 so that I get the number 5. I write it here near this line. So 5 is A plus B's 1 day's work. Next I divide 60 by 15. I get the number 4. I write the number 4 near this line. So 4 is B plus C's 1 day's work. Next I divide 60 by 20. So I get the number 3. I write 3 near this line. So 3 is A plus C's 1 hour work. So I get the following, I have the following interpretations. Total units of work is 60. A plus B's 1 day work is 5 units. B plus C's 1 day work is 4 units. And A plus C's 1 day work is 3 units. What is required to find? You have to find the number of days A takes to do the job alone. So now we have these three interpretations. Using these three interpretations, I can write two times A plus B plus C's 1 day work is 12 units. So that is 5 plus 4 plus 3. In the left hand side, I have 2 A's, 2 B's, and 2 C's. So that's why I'm writing 2 times A plus B plus C's 1 day's work is 12 units. So therefore, A plus B plus C's 1 day work is 12 by 2. So that is equal to 6 units. It means that if all the three persons work together in a single day, they can complete 6 units of work. Now the problem is to find what is the number of days required by A alone to do the job. So I have to find A's 1 day's work. If I could find what is A's 1 day's work, then I can find what is the number of days required by A to do the job alone. So for that, I'm going to use the second interpretation. See here, we have B plus C's 1 day's work is 4. I'm going to use this data, and I'm going to use the data which I have found now, just now. So that is A's one day work is A plus B plus C's one day work minus B plus C's one day work. It is just like writing A as A plus B plus C minus of B plus C. So this is what is important. How do you find A's one day's work from the available data? So we have A plus B plus C's one day's work is 6 units and B plus C's one day's work is 4 units. So 6 minus 4 is equal to 2 units. So now I have in my hand A's one day work is 2 units. So now I have the required data to find what is the number of days required by A alone to do the job. So I have these two things, right? The total units of work is 60 and A's one day's work is 2 units, right? So therefore, the number of days required by A is required by A alone to do the job is the total units divided by A's one day's work. So that is equal to 30 days. So that is the required answer. So if A works alone, he takes 30 days to complete the job. Look at this problem. A, B, and C can do a piece of work in 10, 12, and 15 days respectively. So first let me interpret this statement. So A can do a piece of work in 10 days, B can do the piece of work in 12 days, the same job, and C can do the same job in 15 days. Now I find what is the LCM of 10, 12, and 15. So that is 60. So 60 is the total units of work to be done. And I divide 60 by 10 so that I get the number 6. I put write this near this line. So 6 is A's one day's work. 60 by 12 is 5. So 5 is B's one day's work. 60 by 15 is 4. So 4 is C's one day's work, right? So we have the following interpretations. A's one day work is 6 units. B's one day work is 5 units. And C's one day work is 4 units, right? So now this is the interpretation that I get from the statement. First, the statement in the problem, first sentence. Look at the next one. A, B, and C start working together. So initially, all the three persons start working together, and after 2 days, A left the work. It means that for the first 2 days, all the three persons worked together, right? So look at the statement again. A, B, and C start working together. After 2 days, A left the work, right? So it means that for the first 2 days, all the three persons worked together. So from these three interpretations, we have A plus B plus C's one day work is 6 plus 5 is 11, 11 plus 4 is 15 units. So if all the three persons work together, then in one day they can complete 50 units of the work. Since the three persons work together for 2 days, so I have, so therefore A plus B plus C's 2 days work, 2 days work is 2 into 15, so that is equal to 30 units. So in 2 days working together, these three persons have completed 30 units of the work, right? So what is the remaining units of work that needs to be completed? So remaining units of work, of course, after 2 days that needs to be completed is total units is 60 minus the 2 days work is 30 units. So 60 minus 30, so that is equal to again 30 units. Now look at the statement of the problem. After 2 days, A left the work, and the next after 2 days, B also left. So for the next 2 days, see for the first 2 days, all the three persons worked together and they completed 30 units of the work. Now the remaining units of work is 30 units. Now for the next 2 days, B and C work together, right? So for the next 2 days, B and C work together, right? So for that, I'm going to use these two interpretations, right? B's 1 day's work is 5 units and C's 1 day's work is 4 units. So therefore, what is B plus C's 1 day work? B plus C's 1 day's work is 9 units, that is 5 plus 4. So they work together for 2 days. So therefore, B plus C's 2 days work, 2 days work is 18 units. 2 into 9 is 18 units. So out of the 30 units of the remaining work, working for the next 2 days, B and C completes 80 units of the work working together. So therefore, again I'm going to find what is the remaining units of work to be done. Remaining units of work is now 30 minus 18, that is equal to 12 units. Look at the statement of the problem. Next, after 2 days, B also left, right? So, working for the next 2 days along with the C, now B left the job. B left the job, right? So, it means that these 12 units of work is to be done by C alone, right? C alone completes this. So for that, I'm going to use this data. What is the data? C's 1 day's work is 4 units, right? So it means that 4 units of work is done by C in 1 day. So therefore, 12 units of work will be done by C in 12 by 4. So that is equal to 3 days. I hope you understand, right? So from the third interpretation, we have C's 1 day's work is 4. It means that uh, 4 units of work will be done by C in 1 day, right? So therefore 12 units of the work will be done by C in 12 by 4, that is equal to 3 days. Now what is the problem? You have to find in how many days the whole work will be completed. In how many days the whole work will be completed. So for the first 3 days, for the first 2 days, for the first 2 days, A, B, and C worked together, and after that, A left the job. So for the next 2 days, B and C worked together after A has left the job. And after the next 2 days, you find that B also left. So C worked alone in completing the remaining part of the work, and he required 3 days to complete the remaining portion of the work. So all the three persons worked together for 2 days, and after that A left. B and C worked together for the next 2 days, and after that B also left the job, and C alone worked to complete the remaining portion of the work, and he required 3 days to complete the remaining portion of the work. So the total number of days required is 2 plus 2 is 4. So 4 plus 3 is 7 days. So that's the answer. Look at this problem. It's a slightly different one from the previous models that we have discussed. It talks something about the efficiency of the persons involved. There are two persons involved in this problem, A and B. They have given A is 4 times as efficient as B. First, try to understand this particular sentence or phrase. A is 4 times as efficiency as B. So therefore, I can put it in this way. So the A has more efficiency than B. That is the meaning. A is 4 times as efficient as B. It means that suppose if A takes X days in completing a particular job, then B will take 4 times X days to complete the same job. I put it in the other way. The problem is phrased in terms of efficiency between the two persons A and B, but I'm writing the data or interpreting the data in terms of the number of days required by these two persons in completing the job. So if A takes X days to complete the job, then B will takes 4X days to complete the same job, right? So since B has low efficiency, right? B has low efficiency than A. So if A takes X days, then B takes 4 times the number of days required by A to complete that job, right? So now I'm finding what is the LCM of 4X and X. So that is nothing but 4X. Now 4X by X is nothing but 4. I write the number 4 here, and the 4X by 4X, that is equal to 1. I write the number here. Okay. What else is given? What else is given? Uh, Look at the second part of the sentence. A can finish the task 45 days ahead of B. So first they talked about the efficiency between the persons A and B. A is 4 times as efficient as B, and he can finish a task 45 days ahead of B. 45 days ahead of B. So what does it mean? What does it mean? So A requires X days to complete a job, and B takes 4X days to complete the same job. And what is given in this particular phrase, A finishes the task 45 days ahead of B. So therefore, can I put it in this way, right? A takes 45, I mean, A can finish the task 45 days ahead of B, so that I can write an expression like X is equal to 4X minus 45. So writing this expression is important. How do you write this? See here, this X is the number of days required by A. So the number of days required by A is 45 days less than the number of days required by B. I repeat, the number of days required by A is 45 less than the number of days required by B. That is what is given in this statement. A can finish a task 45 days ahead of B, right? So that is how I get this expression. X is equal to 4x minus 35. So that is 3x is equal to 45, which implies x is equal to 15. X is equal to 15. Okay. So What I'm going to do with this value, x is equal to 15. What is the statement of the problem? You have to find what is the total number of days required to finish the task if both are working simultaneously. That means if both A and B works together, then in how many days the work will be completed. Okay, so let me come back to this picture again. So A's 1 day work is 4 units and B's 1 day work is 1 unit, right? So therefore A plus B's 1 day work is 5 units, right? So this is A plus B's 1 day's work, and the total units of work that has to be done is 4x. So this is nothing but total units, right? Total units of work to be done. So therefore, number of days required by A and B working together is, what is that? Total units. So that is 4x divided by A plus B's 1 day's work, and that is nothing but 5. So 4x by 5 days, right? So now you have the value of x here. X is equal to 15. So substitute x equal to 15. So 4 into 15 by 5, right? So that is nothing but 12 days, right? So the answer is 12 days. That means if A and B works together simultaneously, means working together, they can complete the job in 12 days. You can see that I am using the same approach in solving any problem in of any model, right? So only thing is that you have to read the data properly and you have to interpret the data and know what is, you must understand what is given in the statement of the problem and what is required to find. Look at the next problem. Here also we have something about the efficiency of two persons. Talks about the efficiency of two persons. So there are two persons A and B, right? A much similar problem, but a slightly different one. A is 3 times as efficient as B, thrice as efficient as B. So there are two persons A and B. So who is efficient? A is efficient. He is 3 times as efficient as B. So therefore, if A takes X days, then B takes 3 times X days, right? So 3x days to complete the same job. So when you talk about efficiency, you have to put the number of days has to be reversed, right? Reversed in the sense that A is 3 times as efficient as B. So therefore, when you write it in terms of days, if A takes X days, then B will take 3x days. So as usual, you are going to find what is the LCM of x and 3x. The LCM of x and 3x is 3x. Dividing 3x by x, I have 3 here. I put 3 near this line. And 3x by 3x is 1. So I write 1 near this line. Right. So now I have the following data. Right. What are the following data? 3x is the total units of work to be done. Right. And what else I have is 1 day work is 3 units. A's 1 day work is 3 units and B's 1 day work is 1 unit, right? 1. Okay. Now, what is the statement of the problem? What you are required to find? Find the number of days required to finish the same work if both work alternately starting from A. They are not working together. So the work starts with A. He works for 1 day. The next day B works. That is in the second day B works. The third day A works. Then the fourth day B works and so on. So they work alternately and complete the job. and you have to find how many days are required if they work alternately to complete the job. So for that, what I'm going to do is A's 1 day's work is 3 and B's 1 day's work is 1 unit, right? So I need to find what is the total units of work to be done, right? I need to find what is the total units of work to be done. So only then I can find the number of days. Okay, so for that, what I'm going to do, look at the second interpretation. I mean, in the statement of the problem, A can finish a task 16 days ahead of B. A can finish the task 16 days ahead of B. So this statement is of importance to us. So I can write an expression like this. What is that expression? X equals 3x minus 16. The same way as we wrote in the previous problem. So the number of days required by A, because X days is the number of days required by A to complete the job, is 16 less than the number of days required by B. See how I'm writing an expression for this particular sentence or phrase. A can finish a task 16 days ahead of B. So I write it as an expression, that is, the number of days required by A is 16 less than the number of days required by B. X is equal to 3x minus 16. So from this I can find what is the value of x. So which implies 3x minus x is equal to 16, or which implies 2x is equal to 16. Therefore x is equal to 8. Therefore x is equal to 8. So what I'm going to do with this number 8, right? So therefore the total units of work is 3x. So that is nothing but 3 into 8. So that is equal to 24 units, right? So uh, this 24 units of work has to be completed by A and B working in alternate days. Right? So how to find the number of days in this case? Very interesting problem. So first the work starts with A. So the first day A starts the work and he completes 3 units of work. That is the capacity of A, efficiency of A. He completes 3 units of work in a single day. And the second day, right, because they work alternately, now B starts to work and he completes 1 unit of the work, right? So now from these two facts, we find that in 2 days, 4 units of work is completed, right? Of course, in the first day, A works and he completes 3 units. In the second day, B works and he completes 1 unit of work. So in 2 days, 4 units of work is completed. Of course, you see that the total number of units is 24 units, right? So 4 units of work requires 2 days, right? So therefore, 24 units of work requires how many days? That is what you have to find, right? So that is nothing but 24 into 2 by 4. So that is equal to 12 days, right? So that is the answer. So we need 12 days if A and B works alternately in completing the job. That you can verify. See here, we have already done a bit, right? So the first day A works 3 units. Second day B works, he completes 1 unit. Third day A, fourth day B, fifth day again A, sixth day B, seventh day A, eighth day B, ninth day A, 10th day B, 11th day A, and 12th day B. Let us check it. So here, of course, 3 unit, 1 unit, 3 unit, 1 unit. Here it is 3 units, 1 units, 3 units, 1 unit, 3 units, 1 units, right? So 4, 4, 4, and here 4, 4, 4, right? So there are 6 times 4, right? So 6 times 4 is 24 units, right? 24 units, 6 times 4. So the total number of days required is just we are checking whether our answer is correct. Of course, logically, if you see that if 4 units requires 2 days, 24 units requires 12 days. So the answer is 12.